this lecture, let us see the implementation part of text summarization. So here I want to generate summary from the Wikipedia article. For that, first we need to fetch article from the web, right? So to do so, we'll use couple of libraries. The first library that we need to install is the Beautiful Soup. So here we are executing this command. And this Beautiful Soup, it's a Python utility which is used for web scraping. Then install another important library, LXML, to parse XML and HTML files. So let us execute this command. And as we all know, NLTK should be installed. So NLTK is a leading platform for building Python programs to work with human language data. So here it provides easy to use interface to over 50 corpora and lexical resources like WordNet, and it even provides text processing libraries for classification, tokenization, stemming, parsing. Okay, so for all these things. So install this. So they were those libraries were already installed. And now let us move to the actual coding part. Okay. So here first step is pre-processing. So first we need to remove references from the article. So we are taking Wikipedia. So here references are enclosed in square brackets. So we need to remove the square brackets and replace the resulting multiple spaces by a single space. So that's our task. So first let us take this URL. So I'm taking article from this Wikipedia or from this link. That is severe acute respiratory syndrome coronavirus 2. So I'm taking this article. So you can read that article. And then we are using Beautiful Soup function library to read the or to parse the HTML and XML files. And after that, we are performing pre-processing, right? So let us move to this part. So we are taking one paragraph in set of paragraphs. So initially this article text is empty, right? So now we are appending or adding the paragraph text in the paragraph to article text. Then our task is we need to remove square brackets and extra spaces from the article text. So execute these two commands. And now here article text contains text without brackets. So it contains text without brackets because we already removed square brackets. So we do not want to remove anything else from the article since this is the original article. So we'll not remove other numbers, punctuation marks, or special characters from this text because we'll use this text to create summaries and weighted word frequencies will be replaced in this article. Okay. Then in order to clean the text and calculate weighted frequencies, we'll create another object. So we are taking, so we have article text which contains original article, and we are using this formatted article text which contains formatted article. So we are using this in order to create weighted frequency histograms for the words, and will replace these weighted frequencies with the words in the article text, right? Then now we need to convert the given text into sentences. So for that, we are using the sentence tokenize function. So now, so we need to tokenize the article into sentences. So we'll use the article text. Again, we are passing this article text here. Okay. So here we are using this article text for tokenizing the article to sentences since it contains full stops also. And The formatted article text, this one, it does not contain any punctuations. So because we already removed special characters and digits, so it does not contain any punctuations, digits or other special characters. So as it is not having any punctuations, it cannot be converted into sentences using the full stop as a parameter. Okay. Now our next task is to find weighted frequency of occurrence. So we need to find which word occurred more number of times, right? So for that, to find the frequency of occurrence of each word, we use the formatted article text. So we are taking this variable in order to find out frequency of occurrence because it doesn't contain punctuations, digits or other special characters. Okay. So now for doing this, first we need to store all English stop words from NLTK library into stop words variable. Okay. So we are taking all English stop words. Next, we loop through all the sentences. So here initially word frequency is empty. So it's not having anything. Now we loop through all the sentences and then corresponding words to check if they are stop words. So first we are taking one word and now after this check whether that word is present in stop words or not. So if the word is not in stop words, then you need to check whether the word is present in word frequency dictionary. If if the word is not in dictionary, then you need to add that word and set that value to 1. Okay, so let us assume that there are 10 words and now I want to add those 10 words to word frequency dictionary. Okay, so let the words be natural language processing and so on. So first three words are natural language processing. So first I'll take the word and then check whether natural is in stop words. No. Then move to if condition. Now check whether the word is in word frequency dot keys. So here there is nothing in word frequency. Initially it is empty. So you need to add that word to the dictionary and set that value to 1. So let me add this natural to dictionary and set that value to 1 because it occurred only once. And then second word. So now again check language. Language is not in stop words. It's not in word frequency. So I want to add language. And set that value to 1. Then what is the third word? Third word is processing. So processing is not in stop words or it's not in word frequency. So let me add this CESSING processing. And it occurred only once. And assume that my fourth word is also natural. So then in that case, it is not in stop words, but check if the word is not in word frequency. So natural is already existing in this word frequency dictionary. So move to this else part. So in else part, what we are doing, we are incrementing value by 1 or you need to update the value. So earlier we have 1 occurrence of the word natural. Now it should be incremented by 1 so that it becomes 2. And then assume that it occurred one more time among 10 words. Then again we need to increment its value by 1 so that it becomes 3. Okay. Now you need to find out maximum of word frequency dot values. So after completing this, after reading all the words, you need to calculate the word which occurred more number of times. Max of word frequency dot values. So these are keys and these are values. That means words are keys and their occurrence become value. Now here, to find the weighted frequency, we simply divide the number of occurrences of all words by frequency of the most occurring word. So here we found this maximum value. Now we need to find out, divide number of occurrences of all the words, and then divide that by frequency of the most occurring word. So what is the most occurring word? Natural. And its frequency is 3. So you need to divide this complete value, number of occurrence of all the words, by maximum frequency, which is 3. Next, we need to calculate sentence scores. So initially sentence score is empty again. Now we have to, so just now, so here we first create an empty dictionary, sentence scores dictionary. Here you can see sentence scores dictionary is empty. And then the keys of this dictionary will be the sentences and its values will be the corresponding score of the sentences. So just like how we considered words as keys in the previous case, here we're taking sentences as keys and its value will be the score of that sentence. So for this, again loop. So we loop through each sentence in the sentence list. So we are taking sentences from the sentence list and tokenize the sentences into words. So we are using word tokenization in order to tokenize the sentences into words. And after that, check whether the word is present in word frequency dot keys. So we already generated word frequencies before, right? Okay. So we check if the word exists in the word frequency dictionary. So this check is performed because we created the sentence list from the article text object. And word frequencies were calculated using formatted article text. So which doesn't contain any stop words, numbers, etc. So we do not want very long sentences in the summary. So for that, we are using this condition. So that means we just want only the sentences which are having less than 30 words. Sentence is not present in sentence scores dictionary. We are adding that sentence as a key and value will be the first word in the sentence. Okay, weighted frequency of the first word in the sentence. And if the sentence exists in the dictionary, then you need to move to this else part, right? Then we simply add the weighted frequency of the word to the existing value. And our task is to get the summary. So now we have the sentence scores dictionary that contains sentences with their corresponding score. In order to summarize the article, we can take top n sentences with the highest scores. So here you can see this sentence, it actually retrieves top 7 sentences and prints them on the screen. So we are using this heap queue library and calling its n largest function in order to retrieve top 7 sentences with the highest scores. So let me execute this. So this is a summary which is generated from the Wikipedia article. So which is having only 7 sentences.